Hey, this is Steve from LegitTechTutorials and welcome back to my product development series. Today we are back working on the filament maker, the Fila Factory. Today we're going to be working on the frame because we've done a lot of the other pieces that we need to do already, so the next one is the frame to hold everything. And then maybe do some analysis of different things and see how heat moves. Maybe if we have some extra time, do some analysis of the aluminum extruder head to see how much wattage we're actually going to need to get the heat to go to the places that we want it to go. Yeah, so the frame is the main piece that we are going to be changing on the Fila Factory, between the Fila Factory and the multi-extruder, because the multi-extruder had a steel frame. Everything had to be welded in order to be straight and stuff like that, while with this frame everything is going to use just gussets and 2020 aluminum extrusion in order to make everything square. So it's going to be a lot easier to make things square. All I have to do is cut stuff to size and then, put it into a box so that the end user could assemble it. That way it'd be very small packing size. That way somebody could just pull it out of the box, bolt the gussets together, bolt the gussets onto the 2020 extrusion, bolt the 2020 extrusion together, and then, clamp the extruder head on there, and the electronics box will already be stuck on there, and then just plug in a few things and you're good to go. And also, what I would like to do instead of a lot of the stuff that I did on the last one is make most of the stuff attach via connectors. So extension wires, and then the extension wires, or like on the side of the electronics housing there's connectors, and then you just connect the connectors on there just like you would on a 3D printer, so that way you don't have to have, I don't have to send it where everything is wired in, because all the wires are screwed into terminals inside of the electronics box. I would rather just have very nice plugs on the outside of the enclosure, the electronics enclosure, that will be again 3D printed, so that you could just plug in these connectors and have a good connection and also quick connection, and have them very nicely labeled either by indentation in the PLA or maybe some sort of little layout sticker to stick on the side of the PLA enclosure, where some of the wires are coming out of what I think is probably going to be like an MKS base or an MKS Gen 3D printer board, come out and plug in to those various different pieces. So with that, this is the main part that's going to make the difference as far as the, because technically you could just change the frame of this guy and then put all the multi-extruder stuff on there. So it would work if you just changed the frame, which is what I should have done at the beginning. I should have just used 2020 aluminum extrusion, because it's a lot easier to do stuff that way than to do stuff any other way. And then the pieces that the electronics attach to, I wouldn't even need to do like a bracket. It could just be, bolted with T-nuts. So everything will be held on there with T-nuts. And so I give them a bag of, 20 T-nuts. And then they just bolt it down the table, bolt all the electronics to it, and bolt the extruder head onto it, and then bolt it wherever you want it to, like a table or a wall, and then get to extruding. So very, very fast setup. While the other one did have that, but the issue was the weight. So that's another thing too, is I want to drop the shipping weight. So I had a lot of issues with the multi-extruder. One of the big main extruder pipe breaking free inside the box and just pummeling everything, just breaking everything, breaking the screen, breaking the electronics, breaking welds, even broke some welds. So to do that and minimize my welding, so just minimize the amount of time I have to spend. I would rather spend time making a better extruder head than a piece of galvy pipe than I would want to assembling the frame. Because the frame is just there to hold it. And even when I assembled the frame, everything wasn't always 90 degrees. While these precision manufactured gussets will always hold it at 90 degrees, 90 degrees square. So I just have to cut these things to size, put the right number of T-nuts into a bag, ship it to them, and then they just bolt it together, and then the rest of the time I could spend on building the extruder and also the funnel assembly, etc., etc. Right. The funnel end also have a high precision nozzle, a milled and lathed nozzle with these little square pieces on it. Okay, with that being said, let's go ahead and start working on it. So we got the Fila Factory open over here, and then what we're going to do is we're going to create a sketch, and it's going to have a few things, and we're looking at the top. So let's go ahead and look at this extruder piece, and then we're going to determine what size of this 5 inches. What is it total? $7-inch total. Okay. So obviously what it needs to be is this needs to clear these 2 bars, so that's 5 inches. And now I'll show you guys that, so basically the gap between these 2 pieces of extrusion has to be 5 inches. So what I'll show you guys how to do a ghetto extrusion, aluminum extrusion. Whoops. So what we're going to do is we're going to do insert, attach canvas at the bottom, select an image, pictures, and this one, bring that in, rotate it around. Okay, alright, now we have an attached canvas, and make sure that that's before your sketch, otherwise it disappears. Alright, so now we're in our sketch, and before we go into our sketch, what I'm supposed to do is I'm supposed to go to this guy, and you say edit feature, sorry, it's in here, canvases, right click, calibrate. And what you're going to do is you're going to select as close to there as possible and as close to there as possible. And then you're going to say this is 20 millimeters. Now that's actually to scale. So now when you do that again, if you did calibrate again, and this image should be to size when you go from here to here, this should be 20 millimeters. So when I do 20 millimeters again, it shouldn't really move. So now you see that that is correct. And this is actually how I really like doing stuff, because I could just lay an image down and then mess with it. So let's go ahead and close this. Alright, so now all we're going to do is go here, and then I'm going to put a point as close to the center of this thing as I can. So that looks to be a little bit to one side. Doesn't really matter. Just have to get it as close to the center as possible. That looks pretty good. Then what we're going to do is we're going to draw a line from this corner here, somewhere there or so. Something like that. And then we're going to draw a line from here. And then I'm going to coincide these two. Sort of. Pretty much like that. And then I'm going to make this, these two parallel. Other way around. There he goes. Alright, so basically that's pretty much like that. Dimension this one. It's a little bit bigger. And I'm going to make these two parallel to each other as well. Now those should be identical. Should be the same length of that. Oh. Anyways, that's that should work fine. We'll see how it looks. Okay, so then, oops. So then what I do is I edit sketch, circular pattern. One, just do all that stuff. Center point. So sometimes you can't select. There it goes. So then we're doing 4. As you see, it came out okay. Except for it's got a funky thing going on in there in the center. Okay, so that is basically what the hell is going on. Oh. I forgot to select the, okay. We're going to select that little line right there. Now it looks good. Okay, so stop sketch, hide the canvas, extrude. Okay, so this one, so what I'm going to do here is I'm going to save this. Save as, this is the 2020 extrusion profile. So everything that we extrude is basically going to be off of this. Then what we're going to do is we're going to extrude it, and basically what we're going to need is we're going to need a big one, a big piece that goes all the way up to the top. So it's going to be up to pretty much this point. So this is, you guys remember on this one, this was 5 inches? 5 inches. So it's going to go from the ground all the way up to 5 inches. So I wouldn't say any shorter than the multi-shooter right now, which are 2 pieces of, and also they can be bigger than 12 inch. So I think what we should do is we should do 12-12 again. So a 12 inch piece, 12 inch piece, because they fit in the flat rate box, and the flat rate box will allow us to get the cheapest price shipped internationally. And then if, and also it doesn't count against bigs, because I think past 12 inches you have to pay for oversized shipments. So that's what we're going to do. So this is going to be 12 inches. Just like that. And now I'm going to save this as, this is 12 inch 2020 extrusion. So this is one leg, and then we're going to have a second leg, 1 leg, 2 legs, and then we're going to have the side pieces. And the side pieces are basically going to be the size of the MKS base. What was one? Oh, here it is. Oh, that's the TFT. It's full color touchscreen. I think that's it. But yeah, you can see it's actually, we're looking for the gen. The gen is the one that you pick. The base, the MKS base, is the 3D printer board, because that's basically another thing that we're going to be changing between the multi-shooter and the Fila Factory, is that we're going to use electronics that we don't have to buy all separately. We're going to buy one set of 3D printer boards. So what we're going to use is, since we use a 3D printer board, it's already built to handle motors, it's already built to handle steppers, it's already built to handle temperatures, and it's already built to handle heaters. So, and also touchscreens. It has built-in plugs like this, where you can buy it all in one and, you know, and be ready to go. right? So here, TFT28, so it's a 2.8-inch touchscreen. Well, I'll probably do the same as my last one, where it's a 3.8-inch 3.2-inch touchscreen, full color touchscreen with this kind of interface. And those guys, they plug right in with these two plugs. They plug right into these two sockets, and then it's ready to go. While the other thing, I had to have a shield, and then it took up a whole bunch of extra plugs that I didn't want it to, and you could switch it out with any board and use the same plugs. It's standardized throughout all the throughout all the printer boards and stuff like that. But anyways, so this is the base, MKS base. You'll see here, MKS base. But these have the steppers soldered onto the board. Now we're only going to need to use two. 1, 2. So we need the extruder and we need the filament winder. So we only need 2. So I don't know why we would be paying for five stepper drivers when we're only using 2 steppers. So they have another version called the MKS Gen, where you actually put the steppers in, and then we could buy higher quality steppers for the main extruder, so we could pull a higher current, like 3 amp or whatever, and that way we could pull the higher current off of that piece there. But we're probably going to want something like the MKS Gen Mini or something. There's one of these where I think it's the MKS base. Actually, it's the Mini, because these are big. These are big boards. So what's the size? Well, this is pretty cool. This shows you where all of the digital pins are outputted to. I think this is it. No. Honestly, I might just go onto eBay. Usually they have it. Yeah, there you go. This is on Banggood. 143 millimeters by 84 millimeters. So how big is that? Alright, so what we'll do is we'll create a new, and then we'll actually model it. Okay, so this is, I want a center rectangle. .143 millimeter by I think it was 89. Oops. 84. Okay, which is 3 inches by 5 inches. Okay, that'll work. So basically what we have now is, let's go ahead and do File, New Design. And this is going to be MKS Gen 1.4. MKS Gen 1.4 layout. Okay, so then this one's going to be called Frame. And so we're going to use 2 of these 2020s mounted to each other. So let's go ahead and drag the 2020 in there. So there's one 2020. There's 2 2020s. And now these are going to be attached to each other, so let's go ahead and joint it. Okay, so now that's a total of 24 inches tall. Then, of course, the other issue is having this thing clear. So generally what I used to do to get it to clear is I had a plate on here that was the thickness of this piece here. So let's see what the thickness difference is on this. So the thickness difference is the change in piece here. That's 0.4. That's half an inch thick. That's a little too much. So how would I do that then? Basically, most likely it's going to have to be some sort of spacer. So I'm going to have to cut a special spacer on here, which is not ideal. But let's run with it for right now. So another thing that we're going to need is we're going to need two arms that come off of here at 4 inches from the top here, and 4 inches from this, I think is 1 inch or 2 inches from the top here, and then 5 inches down and then across, and then that's going to hold our MKS gen. So let's go ahead and do File, New. Actually, what I'm going to do is I'm going to go here, and then so we have to go off our MKS gen. How big of a box are we going to need? Let's do 6 inches. Actually, we need this to clear too. So this total diameter 1.5 inch, so on each side, so that's 7.5 inches. So let's do MKS gen 1.636 inches. So let's make that 7 inches for right now. We'll see how that lays out. So go ahead and go in here, and then this is going to be 7 inches. And then we're going to file, save as 7 inch 2020 aluminum extrusion. Go into our frame, drop the 7 inch, and then this guy is going to go, we go back to the extruder, look at the front. That's 1 inch from top to bottom, just like I thought it was. So we're going to go joint, and then this guy is basically going to attach, let's say from the top left here, top left corner, this top left corner. Actually, this is already at 1 inch, so it should be just like that. Because this guy's actually the top is gonna be up here somewhere. So this is gonna clear. This is gonna clear this piece. It doesn't need to be sitting on that piece. Okay, so there's one piece. So there's where one set of our this is where one of our electronics go, and the electronics gonna butt up to this part right here. And then we have one last piece of 7 inch. And it's going to rotate 90 degrees. This guy is going to be the distance here, the distance here plus a little bit, so let's make that 4 inches. So what I'm going to do actually is what I should have done is I should have attached this one first. So what I'm going to do is actually modify this joint and make this 4 inches down. And then I'm going to joint this one up to the top where I jointed the other one. And of course this is why we're modeling it 3D space, so we can look at it and see how things change and how it looks and see what we need to change. Luckily this is so close it shouldn't cause any sort of forward rotation or anything like that. So that looks pretty good. And then the other thing that we would do is we would do some sort of probably just a metal bottom here, or maybe even an extrusion bottom. Maybe we could do some 3-inch pieces of this, cut it here, so we have a whole bunch of 6-inch pieces and then cut them in half. So 2 3-inch, 2 3-inch, and then attach them to the bottom. And then that way we could attach multiple different things to it, or use I don't know why we need to use extrusions. Pretty expensive, but with that it means that we don't have any issues with any bolts hitting the table or anything like that. So that could also be made out of plate of steel or a plate of aluminum. I don't want. Obviously, we're stepping away from steel at this point because we want the light weight. So let's do like a piece of 3-inch. It's probably gonna have to be bigger than that, but let's try it for right now. It's 3-inch. Okay, let's go ahead and put 3-inch down. So it's going to be boom, 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 all the way across. Copy, paste, copy, whoops. Paste. Alright, then it's going to attach this guy to the bottom, and then I want to figure out what weight we're talking about here. That thing's going to be in the way. Oh, no, it's not. It's just like that. Okay, joint again. I don't know which side I picked. Oh, okay, well I picked the right side. Oh, he's gonna pick the bottom left. Pick on that one. So that would be on this side. Okay, so yeah, that I don't know if that's gonna keep it from falling. Might need to go a little bigger than that. But we're at 33 minutes, so we gotta get this show on the road. Oops. Alright, there it is. So let's go ahead and go back into each of these pieces really quick. So let's go ahead and save this. That's pretty much done. Let's go into the 7 and the 12. Sometimes, let's see if it actually wants to give us the weight. Usually it doesn't. Actually, what I have to do first is I have to assign all the physical materials, because these are all steel. But let's just see what it says that it is with so if I go into properties, mass is 1 pound of steel. Okay. I mean that's decent, but see, sometimes it freaks out with that, because if you go to one of these 12-inch, 1 pound does not sound right. See, that's 1 pound. I think whenever you do that, it just assumes the largest one, which is super annoying. So this is 1 pound, this is 1 pound. Obviously 7 inches is going to be like ½ pound. So 2 pounds, 3 pounds, 4 pounds. So about 4 pounds. Now with this guy, basically what we're going to do is go in here and then go into physical material, bring it up, metal, aluminum. Same thing with the 12-inch. Physical material, aluminum. Three-inch, physical material, aluminum. Save them so we can pull it into our other image. Go into the frame, relink them, and just get a rough estimate and then call this video good. Properties, and we went from a pound down to 1/3 of a pound. So 1, 2, and this is half. This is a quarter. This is a quarter pound. No. So basically, it took that other weight. I think it was 1, 2, 3, 4 pounds. 4 pounds and divided by 1/3. So that is 4/3, which is 1.25. Wait, no, 1.33. So 1.33 pounds. So we went from 4 pounds to 1.33 pounds, and that is really good. So maybe we can even ship it domestic for cheaper than the flat rate box. Buy our own boxes. Alright, so with that, that's pretty much it for this video. This has been Steven from LegitTechTutorials. I'd like to thank you guys for watching. If you like this video, please subscribe for more videos like in this series or series as well. I'll see you guys next video. Thanks for watching. Take it easy. Peace.